Hello guys, Samuel here. In this video, we are going to be solving the algorithm problem, longest consecutive sequence. Let's dive right in. The problem reads, given an unsorted array of integers, nums, return the length of the longest consecutive element sequence. You must write an algorithm that runs in big O of n time. Now I'll go ahead to give a visual explanation of the solutions to this problem. A consecutive sequence is a sequence of numbers with each number increasing by 1. Given this array, the consecutive sequences in the array are 100, a sequence of length 1, 200, a sequence of length 1 also, and 1, 2, 3, 4, a sequence of length 4. So the question expects our algorithm to return 4. In this video, I'll be implementing two solutions to this problem. In the first solution, I'll ignore the constraints, which is writing an algorithm that runs in big O of n time. Whereas in the second solution, I'll enforce the constraints. Now let's go ahead to see the first solution. The first thing I'll do is to sort the array. After sorting the array in ascending order, I'll look for the consecutive sequences in the array and return the length of the longest consecutive sequence. So sorting this array in ascending order, this array becomes array of elements 1, 2, 3, 4, 100, and 200. After sorting this array, it becomes easy to see the consecutive sequences in the array. So the consecutive sequences are 1, 2, 3, 4 of length 4, 100 of length 1, and 200 of length 1 also. So my algorithm will return 4. The runtime complexity of this algorithm is big O of n log n, and that is because I had to sort the array first. Since the problem asks us to write a solution that will run in big O of n time, I will not be implementing this solution in code. However, the code implementation of this solution can be found in the GitHub link included in the description. Now I'll go ahead to explain the second solution. Before we dive into the second solution, I kindly request that you give this video a thumbs up and subscribe to my channel to indicate your interest in content like this. Thank you. The first thing I want to do is to give an analysis of a sequence. So given the sequence of numbers 1, 2, 3, and 4. 1 is the first element of the sequence, and that is because 0, which is the number before 1, does not exist in the sequence. So after getting the first element of the sequence, I can keep incrementing the numbers by 1 to get the remaining elements of the sequence. So in this second solution, what I'll do is I'll go through each element in the array. If an element is not the beginning of a sequence, I'll ignore that element. However, if it is the beginning of a sequence, then I'll check for the existence of other numbers in the array that belong to the sequence. To check for the existence of an element in the array, I will not be directly looking into the array. And that is because to check for the existence of an element in an array takes big O of n time. However, it takes constant time, big O of 1 in a map. So I'll put every element of the array into the map and then check for the existence of an element in the map. And in JavaScript, an object is an implementation of a map. So I'll go ahead to put all the elements of the array into a map. Now I'll start iterating over each element in the array. The first element in the array is 100. Is 100 the beginning of a sequence? Yes, it is the beginning of a sequence. And that is because the number before 100, which is 99, does not exist in the map. And so that implies it does not exist in the array. So I'll have a sequence beginning with 100. Now I'll check if the next number in the sequence, which is 101, exists in the map. 101 does not exist in the map. So it means this is a sequence of length 1. And I'll save that value in a variable which I'll call longest. Now I'll go to the next element in the array, which is 4. Is 4 the beginning of a sequence? No, 4 is not the beginning of a sequence. And that is because the number before 4, which is 3, exists in the map. So I'll ignore 4. Now I'll go to the next element in the array, which is 200. Is 200 the beginning of a sequence? Yes, it's the beginning of a sequence. And that is because 199 does not exist in the map. So I have another sequence here, 200. Now I'll check if the next number after 200, which is 201, exists in the map. But 201 does not exist in the map. So this is a sequence of length 1 also. And since the length of this sequence is the same thing as the length of the longest sequence we've seen so far, I'm not going to update the value of this longest variable. Now I'll go to the next element, which is 1. Is 1 the beginning of a sequence? Yes, it is. And that is because 0, the number before 1, does not exist in the map. So I'll start another sequence here with 1 as the first number in the sequence. Now I'll check if 2 exists in the map. Yes, 2 exists in the map. And so I'll add 2 to the sequence. Now I'll check if 3 exists in the map. Yes, 3 exists in the map. I'll add 3 to the sequence. I'll check if 4 exists in the map. It does. I'll add 4 to the sequence. Now I'll check if 5 exists in the map. 5 does not exist in the map. So that ends this sequence. So this sequence is a sequence of length 4. And since 4 is greater than the length of the longest sequence we've seen so far, which is 1, I'll update the value of longest to be 4. Now I'll go to the next element in the array, which is 3. Is 3 the beginning of a sequence? No, 3 is not the beginning of a sequence. And that is because 2, the number before 3, exists in the map. Now I'll check if 2 is the beginning of a sequence. 2 is not the beginning of a sequence because 1 exists in the map. So now I'm done iterating over every element in the array, and the length of the longest sequence we've seen so far is 4. So my algorithm will return 4. The next thing I want to talk about is the time and space complexity of this algorithm. The time complexity of this algorithm is big O of n. And it is big O of n because I am going through each element of the array once. And for each element of the array that happens to be the beginning of a sequence, to check for other numbers that belong to that sequence, I am doing that in constant time, big O of 1, because of the map implementation that I have. The space complexity of the algorithm is big O of n also. And this is because of the extra space I'm using for the map implementation. Now I'll go ahead to implement the solution in code. So the first thing I want to do is to check for the existence of an edge case, which is if the input array norms is empty. So if the length of the input array is equal to 0, then I'll return 0. So next I'll declare a variable that will hold the map. I'll call that scene. And I'll set this to an empty object. Next, I'll go through every element of the input array and add them to the map. So I'll have each element as the key, and I'll set the value to be the Boolean true. The next thing I'll do now is to go through each element of the array again and then check if it's the beginning of a sequence. So I'll save each element in a variable which I'll call current. Now, if current is the beginning of a sequence, it means that the number before current, which is current minus 1, does not exist in the map. So I'll set a variable which I'll call temp longest, and I'll set the value to be 1, which means I've seen the first element of the sequence. So I missed a step here. I would like to declare a variable which I'll call longest, and I'll set the value of this variable to be 1. So longest will hold the length of the longest consecutive sequence we've seen so far. And I'm setting it to be 1 because since I've confirmed that the length of the input array is not empty, it means I have at least one element in the input array, and that implies that at least the length of the longest consecutive sequence in the array would be 1. So the next thing I want to do is to check for the existence of other elements that belong to the sequence. So as long as the next number exists in the sequence, I'll increment temp longest by 1, and then I'll update the value of current to be the next number after current. Once I get to the point where the number after current does not exist in the array, then I'll go to check if the length of this current sequence is greater than the length of the longest sequence I have seen so far. If it is, then I'll update the length of the longest sequence I have seen so far. So longest becomes the maximum between the length of the longest sequence I have seen so far and the length of this current sequence. Now, finally, I'll return longest. So now I'll go ahead to run this code for correctness. It has passed. I'll submit. The submission was successful also. That's it for this video. Thank you for watching. If there's a problem you want me to solve in an upcoming video, kindly let me know in the comment section. I'll see you guys in the next one. Happy coding.